Hello all, welcome to Robopreneur. Today we are going to discuss about ROS. So let's get started. So yes, first of all, what is ROS and why use it? So ROS stands for Robot Operating System. It's an open source meta operating system for your robot. It provides the services you would expect from an operating system, including hardware abstraction, low-level device control, implementation of commonly used functionality, message passing between processes, and package management. Well, this is a very big definition. Let's break it down. So, meta operating system. It's not complete operating system. Means it will use the services of the existing operating system in which it is installed. Like suppose if it is installed in Linux, it uses some of the features from Linux and act as operating system. Hardware abstraction, so it like provides an interface between the hardware what we are using and between the user, so that is hardware abstraction. And then message passing between processes. So there will be number of processes going on in ROS, like for example camera function, or maybe some path planning, or etc. So how they communicate? They will be communicating with messages in ROS, which will be seeing soon about that. And package management. So there will be a number of packages in ROS, and they all can be managed with ROS. And then low level device control. So this low level device control is, suppose let's say we are using one camera for one particular application, and we want to upgrade, or maybe we want to change the application, we want to change the camera. So in that case, it's enough if you just install the drivers of the new camera into ROS, and you're good to go with your existing code. So that's what it's meant by low level device control. Okay, so that is about ROS. And why use it? Well, one of the main application is it helps to avoid reinventing the wheel. What do you mean by that? Let's say, suppose let's assume that we want to do this path planning. There is one popular path planning, that is Monte Carlo localization. There is one popular path planning algorithm. If you want to write that from scratch, it will take you let's say 4 to 5 months to do it, complete path planning. So ROS has already a package to implement that path planning. So there is something called G mapping, which will be seeing that later in later sessions. So using that, in that package already this Monte Carlo localization is implemented. So using that, we can modify that according to our needs, and use it for whatever application we are using. So that is one of the main uses of main applications of ROS. Why ROS is mostly used in industries, for industrial applications. In fact, it's used in very big organizations like NASA and Boston Dynamics, such organizations. Okay, so that's about ROS and why we use it. And then let's move on to some of the robots made with ROS. So this is prosthetic arm. I hope most of you are aware of prosthetic arm. So it's like artificial arm. This can be made by ROS. You know, it's almost human like. And the next one is Crane X7. This is developed by one of the industry. So it has 7 degrees of freedom. And the other one is Meg Rover. So this is used in industries for transporting the load from one place to other. So its payload is around 40 to 50 kg. So it can transport 40 to 50 kg from one place to other very easily. So now that we have seen some of the robots with ROS, let's move on to see what is this ROS 1 and ROS 2. So ROS 1, actually ROS was started way back in 2007. So but then newer version of ROS came up in 2017 or 2018, somewhere around that. So that's why the architecture is different. So there are many differences between those two. If you broadly, I mean, the main differences are ROS1 is a monolithic system, while ROS2 is a modular system. So monolithic is like most of the functions inside that operating system are administrator controlled, whereas modular system, the only the important functions will be under administration control, and the other functions will be under the control of the user. So that is modular system. And the second difference is ROS1 uses a central broker to communicate between nodes, while in ROS2 nodes communicate directly. So this is one more difference, one more important difference. So in ROS1, for any communication to happen, it should go through a central broker, while in ROS2 that's not the case. Yeah, so that we will more clearly understand when we do an activity. And the third one is ROS1 has more user base, while ROS2 has a better security. So ROS1 has, I mean, more, since it's been there from long time, so ROS1 has much user community and much support, while ROS2 has better security. But yes, the support for ROS2 is also growing in the community, in the robotics community. And that's about it. And yeah, so one more important point is, as of today, most of the hardware is compatible with ROS1 rather than ROS2. ROS2, yes, we can develop what all are done in ROS1 in ROS2, but when it compares, when it comes to the implementation of ROS on hardware, then most of the hardware as of now is compatible with ROS1. I mean, whatever you do, ROS1, the ROS1 hardware performs well with ROS1 compared to ROS2. So of course this is fast changing. Maybe in the coming 2 to 3 years, ROS2 may replace ROS1. So the hardware manufacture and all, yes, that's happening, and the manufacturing of processors, the manufacturing of hardware to be compatible to ROS2, all this is going on in industry. So maybe in the coming 3 to 4 years, ROS2 is going to overtake ROS1. So and ROS1, actually the organization which uses ROS will actually release a different version. So let's just have a brief look at different versions of ROS. Let me just make a small Google search, because even I don't remember all the names. So yes, here it is. So just let's see the distributions. So yes, as you can see, these are all the versions of ROS1. So from 2010, almost every year different versions have come up. ROSBox Turtle, ROS-C Turtle, ROS Diamondback, ROS Fuel Turtle, and ROS1 is ROS Noetic, which is released in May 23rd, 2020, and it ends by 2025. So after 2025, we can say that officially ROS1 will be like versions of ROS2. So this is the list of distributions. So you can see ROS2 is around since 2016. So beta 1, beta 2, beta 3, Ardent, and you can see a number of versions. And Foxy is so the last one is latest one is Humble Hawksbill, that is released in 2022 May 23rd, and its EOL is May 2027. So it's quite a stable version. And you can see one of the trial or unstable version, that is Galactic. So Galactic Geocalone. So it's quite difficult to pronounce, but anyway, so it's released on May 23rd, 2021, and its end of life is December 29th, 2022. So it's like intermediate version. So its EOL has already expired. And another stable one is Foxy Fitzroy, that is released in June 5th, 2020, and its end date is May 2023. So probably by the by the end of first half of this year, its support is going to expire. So this was just to show that there are different versions of ROS 1, ROS 2 existing. Okay, so now that we have gone through the different versions and we have gone through the important differences, so let's go and do some hands-on. So we will, before doing hands-on, let's discuss briefly what actually is inside ROS. So anyway, while doing hands-on, you will get to know better. So it's like, for every ROS application we do, we will create a workspace. Inside a workspace, we'll create a package. Inside a package, we'll have nodes. So you can say that node is the minimum, node is the smallest entity in ROS. So yeah, so now that we have seen this briefly, let's go to the terminal and then just start doing the hands-on. So first of all, let me open the commands, the list of commands which we are going to do for different purpose. So yeah, before we actually do it, it's a good practice for while working on ROS. It's a good practice to open 3-4 terminals so that you can parallelly see what's going on. So the first terminal I have opened, and let me go down and make 3 more copies. New window, and then another one, and then another one. So now let me arrange it on the screen so that it will be convenient for me while working. So yeah, so this is terminal 2, and this is terminal 3, and this is one more terminal. Yes, so we have 4 terminals here. Yeah, so we have 4 terminals here. So now I have opened all the terminals. So let's go over it one by one. So let's go over the procedure step by step. Yes, so first of all, we have to source the setup file. Actually, for every terminal we open, there is something called bash rc which executes on itself. So we have to source the setup file so that we don't need to run these commands every time. So let me open bash rc and show it to you. So yeah, so let me open it. The command is gedit space. So actually you can use any other editor which you are comfortable with. I am using gedit. So gedit, and then let me move the terminal side. Yeah, so gedit and tilde dot bash rc. So it will get opened. So as you can see, the last 2 lines I have already added. So these 2 lines should be added to bash rc so that we avoid typing these again and again while running any ROS program. So this is just that like a one time thing. So you just have to do it, and that's it. Whenever you open the terminal, these commands automatically get executed and you don't have to type it manually again and again. The second command should be done, the second command should be entered after we create the workspace. So let me show what it means. So let me go back and let me minimize all this, and yeah, here we go. So first of all, let me close this bash rc. I anyway have to do it again anyway. So now the second one, let me check this again. Yes, so now first let me create the workspace. So in order to create the workspace, it's just like we have to create a folder. So ls, so these are all the folders, just to view what all are there. Now let me create the workspace mkdir, that is folder. So mkdir, and then it's let's name it sample workspace, a simple name. So yes, I have created the directory. Now you can see that we have this sample workspace over here. Let me clear the terminal. It's a good practice to keep on clearing the terminal. uh, then let's move on, let's navigate to this workspace. Yeah, so our workspace name is sample workspace, so let me navigate to it, cd sample workspace, and then let me create one more directory called src. So this is where we will store our code, we'll save our code. Sorry, it's not cd, let me make the directory first. So mkdir src, and yes, as you can see, this is already there. So now this is what we have created just now. So yeah, let me clear this again. So now once this is done, and now let me make it. So cd, let's go back. Yeah, so now we should be in this sample workspace directory. Okay, so now let me do this catkin make. So this is where we will actually make ROS to understand that yes, this should be included in the this should be treated as something which is related to ROS. So now it's building. Yes, so yes, so now we have completed building. Let's see what all are there. So as you can see, previously we have created src. After building, we have this build and devel directory. So just let's go through them, just go into them quickly and see what all are there inside them. So cd build, so all these are available inside build. Now let me go back a step, and then let's see what is there in devel. So yes, so inside the devel also you have setup.bash. So this also should be run, this also should be execute, this also should be inside that bash rc file, so that it will be executed every time we open a new terminal. So let's include that as well. Let me open the bash rc once again, so that I can open it, so that I can enter these. So minimize this. Yes, bash rc. Oh no, I think I have not typed the command properly. Let me check it again. So I think I can close it. Yes, so gedit, so it's gedit bash rc. Yes, so now the bash rc file is opened. Now let me copy the path here, where we have that setup.bash. So that's, as you can see, it's sample workspace devel, and then you have setup.bash. Let me do that. So source, sample workspace, then devel, and then setup.bash. Yes, so I think this should do. Now we have added that to the workspace, so added the setup.bash in the bash rc file, so that we don't need to type this again and again when we are running the ROS commands. So now that this is done, let me go back and let me clear this terminal. So yes, so now we have created a workspace, and we have actually built it, and we have we have used the command catkin make to build it. And now let's go on and make a package. So in order to make a package, now we have to go to the src directory. Let me go back, let me see the list of folders. Yes, so our folder is sample workspace, and then we need to navigate to src. So now we have navigated to src. Now we have to create a package. So in order to create a package, let's see, catkin. So the command is catkin create package, and we have to give the package name. Let's say the package name is sample package. These are just random names, and then we can specify the dependencies. So let's specify the dependencies ROS cpp, ROS py, and std underscore messages. So these are the three dependencies we have specified. So there are actually a lot of dependencies. So and one more important point is you can program in C++ or you can program in Py in ROS. So we can say that ROS is language agnostic, means it's independent of the programming language used. That is, we can use C++ or we can use Python. Okay, so let me type enter. So now that we have created the package, now let's move on, and now let's go to the package folder and see what it is. So yes, we have named it as sample package. So let me go to the package, and yes, you can see that we have cmakelist.txt, include, package.xml, src. So I mean, if the package is created properly without any error, so these we will find these files, and the XML file, the cmakelist.txt file, and include folder and src folder. So this is what we have successfully created a new package. Now that we have created a new package, now let's now as of now we have just created the package. Now we have to build it. So in order to build it, we have to go to sample workspace again and type catkin make. So always whenever we have to build a new package, we have to, and you can see the name of the package. You can see that the sample package is being displayed here. So whenever we have to build a package, we have to navigate to the workspace folder and then type catkin make. Okay, so now that we have built the package, now let's go to the, let's create a small node. Let's create a new node, a simple node, very simple node. So let's see what are the directories. So src and then sample package. This is the package which we have created, and then you can see that we have cmakelist.txt, include, package.xml, src, like I have told before. Now inside src, so actually we can write the node in src directly, but however let's make it exclusively, let's make a small folder, let's make a new folder and type our script there. So this folder is just for Python scripts, so Python programs. So I have made a new directory called mkdir.scripts. So I'm sorry, let me remove this. There's a typo. Let me remove this. Okay, fine. So let me go ahead with this. So I just have to remember the spelling. Okay, fine. So scripts is scripts. Okay, anyway, scrpits is what the folder I have created. Now let me navigate into this, and over here let me create a Python script. That is what is a ROS node. The Python script which I am going to create is ROS node. So I have already made a small script, simple script. So yes, so this is my first node. Let's go over the code. Let me go back to documents. No, it's not in documents, home, and we have made this a sample workspace, and let me go there and sample package, and in this folder let me paste it. Yes, so this is my first node. Let me see what is there. Let's see what's there inside. So yes, this is a very simple node, which actually just prints the message that this is started. I mean, node has started, and it will keep on printing hello. So here we will import ROS_py, like we have seen while creating the package we have given the dependency ROS_py, so we can use it now. Since we have given it there, we can use it now. And then if you are familiar with Python, if name equal to main, this is the point where the code starts to execute. So here it will initialize the node, my first Python node, and it will just display the message that this node has been started. And the next one is ROS_py.rate. So this is where the ROS_py.rate is something, means here it is given as 10. It means that it is the frequency of the node, it is the frequency of the printing, that is it prints 10 times each second. So and rate.sleep, so it's like it sleeps for 10, so since it prints 10 times in a second, so 1/10 of a second it sleeps and then keeps on typing hello until we press Ctrl+C. Let's see that in action. So first let me go back again, let me clear this, let me go back, and yeah, first of all, to run the code we have to open a ROS master. So that ROS master is the, like, so in the at the beginning, as I was discussing, every communication goes through a master node. So that master node is this one, and it will be opened by the command ROS core. So let me type this. Yes, so ROS core, that is ROS master, the master node has been started. Now let me run the first node whatever I have opened. So actually we can go inside the directory and run the Python script, but it's not a good practice to do that. We can actually run it directly without navigating into the folder. So the command for this is ROS run package name and executable name. So ROS run, our package name, what is the package? So yeah, so the package name is sample_package, and the node name will be my first node.py. So yes, it's not found. Let me get back and see. Maybe let me check the spelling. Sample package, yes, let me check that. Sample package and my first node.py. Okay, so fine. So let me restart this, but before that there is something which I should be doing, that is I have to make this as executable. I have not made it executable. Let me tell you how we make it executable. So let me clear this and cd space let me see the list. So cd space sample workspace and then cd space src and cd space sample package, and then here we have cd space scrpits. So yes, so this is my first node. So let me make it executable again. Executable. Okay, so it's made executable. Now let me clear it and let me run the ROS node. First let me run the ROS master, so that is ROS core. Okay, and then we will actually ROS run. We will do the ROS run. Let me check the command once again. ROS run package name and executable name. So ROS run, so let me run this. Okay, so yeah, let me restart the terminals again. There may be some problem here. Let me reopen the terminals again. So yes, okay, I have opened the terminals. Let me check this again. So ROS core, yes, so ROS core, and then let me run this command again. ROS run and package name. So our package name is and the name of the script is my first node. Okay, so let me check, maybe I might have made small mistake. Okay, so okay, first let me check ROS run. Let's check the graph first and then we can proceed. Okay, ROS run graph. So yes, it's running. So this is actually this is like ROS out. You can see this ROS out. So this ROS out is the master node which I was talking about. So through this all the nodes communicate. So let me check why our node is not running. Let me check this. Okay. So let me navigate and check to the workspace. ROS run and sample workspace and my first node.py. Okay, so let's run it normally. I think there is some something is missing there. So let's run it normally. Let me navigate to the folder and then run it there itself. So cd sample workspace and then cd src and then cd sample package and then cd scripts, and then let me run it normally and show it to you. Python 3 my first node.py. Yes, as you can see it's printing hello. Let me go to the graph and show it to you how it looks like. ROS run rqt graph. So again here rqt graph is a package, and inside that rqt graph is another node. So now you can see this is my first Python node which I am running right now, and this is published, this is actually published on the topic ROS out, and this is the master node. So whatever topic we run, whatever node we run will be published on the master node. So the same thing can be achieved by ROS run command. Maybe some step I may be missing, but yes. So but yeah, the same result can be found from ROS run as well. So yeah, so yes, so right, for today I think that's it for today. We have just had a brief introduction about ROS, and we have created a new package, and we have created a node, and we have run it, and we have seen the graph. So in the next session we will actually discuss more interesting topics like publisher, subscriber, service, and then also we will also try to see gazebo as well in the next session. So that's all for this session. Thank you.